Hi there. Today I'm going to tell you about work, energy, and power. But it's going to be a really tough, long topic. So I'm going to choose the work and the behavior of work and the mathematical model of work, how work is going to apply with physics explanation and mathematical explanation. What is work? That is the product of force and distance. You know these things. Your minor age is even. See, an object you can drag along a force of F towards somewhere and do a work. Every day we do work. When you're in the gym, you lift certain weight. And a tug of war, you drag and you try to push a certain heavy object like a table. Anything that can be a work done, again friction, gravity, or anything else, or spring force, whatever. So the topic is a very deep one. Let's move into, I'm going to explain this via certain animation. Watch the video till the end. Okay,
The work, what is work? I will just explain you now according to you that now that this is nothing other than the product of force by distance. As you can see, the object is being dragged along by a force of F along that comes to that position of D from the original position. So you can just find out the force work done by, again I'm reminding you, force multiplied by the distance. So the equations can be simplified like W is equals to F multiplied by the distance that of D. Okay, then the units is going to be N from this force and the meters from the distance, and the unit is going to be Nm, or in other way we can just say the joule, but we normally use joule for the energy. Energy and work done are just like twins, but a little bit slight difference. Ignore it and just study. Okay, have a good look at. Now I'm going to show you a certain simple a force of 20 Newton applied along a certain horizontal path for some 5 meters on an object that is just going to keep continuing with 20 Newton. So let's find out the work done. This is the work done is going to be really simple. It is like force multiplied by the distance. So the force is 20 Newton and the distance is 5 meters. The W is going to be equals to 100 Newton meter. That is really simple. So let's go for an example. You have to remember always the work is done always against something, as I mentioned earlier even. So the first can be against friction, against gravity, against a spring, against anything, against your opponent, against your friend, something else. So opposing force, you are always trying to just undone certain opposite force. Really simple. In this diagram, the diagram A now is in contact with the B and is going to drag by a certain external force of F, and there will be a certain force of FF, that means the frictional force effect between the surface A and B. I mentioned it here because in my previous videos I would discuss about how this friction generates because of the roughness of the surfaces. Now it's just a simple demonstration. If you want to see that, just go back to my previous videos. I've given in them in the description and watch the video to learn about what is friction. Now come back to this lesson again. In this lesson, it's all about work done. You always do the work against what work against, nothing other than the frictional force FF. So you just keep it dragging along the path for under the frictional force to here to some distance of D. Okay, let's find how does it happen now. Now you can see that the A and B in contact, it's been moved from position, let's say the position as X, and to the position of Y. The distance between those two surfaces is simple D, and we know the work done is equals to force multiplied by the distance. So the force is nothing other than the frictional force. We done the work against friction. So I am just about to write something new. That means mg is the downward force, and there will be the R or reaction force just opposite to it, just opposite. Okay, now the R is equals to mg, and now I'm going to substitute it to here, the F equals to mu R from the frictional equation. Now it's going to be R is equals to mg, then R, when you substitute R with mg, the force becomes mu mg. So when you substitute it over there, the work done is going to be W is equals to FD. W is going to be mu mgd, right? That is it. Now let's have a look at a certain example at here. So it's mentioned like the mass is 10 kilogram and the frictional coefficient is between the two surfaces is 0.5 and the gravitational acceleration is 10 ms minus 2 and the distance d is some 2 meters. Let's say how to find out the work done. It is the equation, finalized equation is W equals to mu mg. Now I'm going to substitute here 0.5 for the mu and the mass is 10 kilogram and the gravitational acceleration is 10 ms minus 2 or the newtons per kilogram. However, I'm now just going to substitute the distance as 2 meters from these locations to x to y, and the work done is going to be 100 joule. You have done a certain work done against friction like 100 joule, or you may write it like 100 Newton meter. Simple. Now let's have a good look at another thing, new thing. The other thing is the work done against gravity. How you are just going to lift something up, weightlifting or lifting on body up to some height, anything it can be, whenever something lift against gravity, but the value for g is only valid for few meters just above the earth. Like for A-level calculation we take it like to 2 kilometers even for some time, but it is not accurate. But for satellite motion, when lifting a satellite to higher altitude, we can't use the equation, we have to go for gravitational equations things. So the link is just given in the description about gravitational force. You have to if you want to just study how to lift the satellite to a orbit, it's a different case. You can't use the g because it's going to vary rapidly. You may have seen those videos, the zero gravity things in space centers and the things, remember them. So now I'm just going to talk about something, just lifting a thing from the earth to some little bit higher, few hundred meters maximally, like that. Okay, now you lift the mass of 5 kg up to a certain height of d, that d is equals to 4 meters. You do a work against gravity, because why? Gravity pulls the object down, is the weight. So the w is equals to mg, the weight. Now you just do that against weight. W work done is equals to fd from the basics, and the wf is equals to mg. The mg is downward and the f is upward, so the mgd. And so m is just 5 kilogram and the gravitational acceleration is 10 newtons per kilogram, and the distance is 4 meters, and the work done is what? 200 Newton meter. The work done is 200 Newton meter. Really simple thing. Okay. So now the new topic is to talk about energy. Energy, that is the definition of ability to work. There are different types of energy: thermal energy, radiant energy, light energy, chemical energy, nuclear energy, electrical energy, gravitational energy, or mechanical energy. I'm going to discuss those things in my very upcoming video with the mathematical approach and the basic explanations and law of conservation of energy, work and power, many more to come. I'm not having any intention to lengthen this video furthermore. Now I'm going to stop from here, and like and subscribe to my channel and get more updates. So hit the bell icon. Whenever I upload that video, you will get the notification. Okay guys, God bless you.